So dear participants, let's get back with our discussions on programmable logic controllers. We are now dealing with the timer section of the programmable logic controllers. We have already come to know what are the different types of timers that are available with PLCs, how they are actually described in this of your uh, ladder language, and what are the different types of timers are there, how they are depicted in the ladder language, how they are applied for certain basic applications, and how they can be cascaded or sequenced for longer delay generation. All these sort of things we have seen already. Now this particular topic which we are going to discuss on right now, it is going to be a bit applied short in nature, because here we will be discussing the actual applications where the timers are used. Here everything I will not discuss completely, because some part of them I would like that you also put up your brain, tease yourself, so that you can actually get expertise in thinking that how PLC ladder logic actually work for applying them in real life problems. So we will straight away get into the applications. In the very first topic that I have taken is the basic on delay operation. Now here the problem is that of a grinding operation. Okay, we are carrying out grinding operation on a metal part, and coolant flow on that part must be on for an interval before the grinding process starts. Now when this particular aspect is there in front of you, then how should you think the process? So you can just get a picture in your mind that who is getting on first. You can see, although the grinding operation is the main operation, here first thing that gets start is the flow of the coolant. So you can directly connect the coolant to the on switch. When you put that switch on, your coolant starts flowing. Once the coolant starts flowing, then you can give an interval to start the grinding operation. This interval may be given for the period that you want, or that is required for the process. It may be 4 minute, 5 minute, 8 minute, whatever it is, or it may be 5 second, whatever it is. So initially the coolant flow has to be started, then there should be a delay, and finally you should start the grinding operation. So now we can say that this is basically a very simple on delay operation. You delay the on of grinding process, or you delay the start of grinding process. This is the basic thing that you need to understand. Now you see here, for that purpose we have given here that how the wiring has to be done. This is I have done for only this example. For rest of the examples I will not show this. This is just to give you an idea. You can see here there is the switch, here there is the switch. This switch is IN001. So once you put this switch on, then the system comes into action. Now how the rest of the things have done, you can see here that here the coolant motor has been connected. So coolant motor is connected to terminal 17, and this of your grinding motor is connected to terminal 18. Now you can find that once we put on this switch, this coolant motor will start immediately. After the coolant motor is started, you can see that once the coolant motor is started, this contact which is associated with that of coil number 17 or terminal 17, this will also be closed, because earlier this was open, because this particular thing was not started, because this switch was not on. Once this switch is on, this contact will get closed. Now when this contact will get closed, then what will happen? This particular timer block, it will start counting. Now when it will complete the counting of 8 seconds, then this coil will be energized. Now when this coil will be energized, your grinding motor will start. That means your grinding operation will start acting. So this is the basic delay operation that you have seen. So this you can find. I also have got it from one of the textbooks that is there in your syllabus. You can also refer the textbooks for more of such applications so that you can become more versed with the concepts. So let us go for. Now let us look into another application. This is application of the basic off delay operation. Now at this point of time, I would like to make one thing very clear, that here, as I am talking about the situation, I am also suggesting you the particular type of action that has to be taken care of. That is why I have written here basic off delay operation. But when you are working on the situation in the field, this particular help will not be available to you. This particular help means, I would like to say that this is going to be solved by basic off delay operation. This is not going to be available to you. Therefore, you need to be very careful about the process that is taking place, and accordingly you should understand it, and then you should decide that which action you are going to deal with. So this is one very important aspect that you need to understand, that this yellow block, this is right now a support for our thinking, but when we actually work in the field, this particular help will not be available to us. This we need to understand. Now let us go for this problem. What is it? Here we have a motor and there is a lubrication pump for the motor. Both of them are in running condition. Now the lubrication of this motor bearings is required during the motor coast down. Coast down means that when the motor is cut from the main power supply, that is the power supply is off, the motor does not stop immediately. A certain time is required to get the motor in complete static condition. That means the motor will rotate by dint of its own inertia and then it will stop completely. This process is called coasting down of the motor. So now you see what is the basic point. After the main motor is shut off, the lubricating pump has to remain on for a time corresponding to coast down time. So in order to solve this problem, you should first determine what is the coasting down time of the motor, and then you should go for the off delay operation. Now this is one approach to solve this problem. You can see here that the motor is connected to coil number 17, that is output terminal 17. It is where the motor is connected. The motor is powered to this contact IN001. Now you see here we have the time delay, and the lubricating pump, it is connected to the terminal 19. Now you can find another thing, that this lubricating pump is also energized from the same input as that of the motor, that is IN001. So when you start the motor, you are starting lubricating pump simultaneously. But now you can see that there is another contact. This is NC contact. Now this NC contact corresponds to the coil which is actually controlled by the output of the timing block. Now you can find that what is written there, that this coil is normally timed out. It is reset to 0 when the motor starts. How it can be done? So you can see here, when the motor actually starts, this particular terminal, that is taking care of the reset terminal. When the motor is started, that means this contact is closed. When this contact is closed, this contact is also closed, and this contact is also closed. So here the motor is reset. Now when this contact is open, this contact also gets opened. This contact also gets opened, and the reset contact also gets opened. So when the reset contact is opened, now your timer block is able to work. And when this contact is open, that means that there is a transition from on state to off state. Now when there is the transition from on state to off state, this delay operation will start and it will count till 20. Now you see that when this output coil is not activated, then this contact will remain closed, because this is a normally closed contact. This is the normally closed contact and it is corresponding to this coil. So under normal condition, when this coil is not activated, then this remains closed and your lubricating pump is on. Now you see that once this is off, there is starting of counting by this counter, and when this 20 seconds is over, this coil is activated. When this coil is activated, this NC becomes NO. That means this contact becomes broken. When this contact is out, that means this contact is no more there, the lubricating pump will be off. But now you can see that when we put this off, after 20 seconds the lubricating pump will be off. And you can see also here that since we are using the same input switch for the motor and the lubricating pump, we need this latching contact also, because when this switch is kept off, in order to put off the motor, then since the lubricating pump is already on, the coil associated with the lubricating pump is already on, the normally open contact will definitely remain on. So when this is remaining on, then whether this particular terminal is present or not, that means whether it is closed or open, there is no problem. Electricity or the current will find its path in this particular way. However, when this particular terminal is activated, then this NC becomes NO and your lubricating pump will be off. So this is how a basic off delay operation takes place in practical field. Let us now see the example of limited on time, that is interval operation. Here we need to consider an wood sawing operation. The sawing operation actually takes place for 4.6 seconds. However, there is a blower that is applied to blow the sawdust, and that blower should be kept throughout the process. So the blower should be kept on throughout the process till the operation is on, and it is required that this wood sawing operation takes place for 4.6 seconds only. So for that, let us see one thing, that here that is the ladder logic. There is one printing mistake only, that this should not be an NC contact, this should be an NO contact. That please you remember, because I have taken from the particular book where there is this mistake, what I have come to know. Now you see here we have taken care we have taken this particular input switch, this is an NO contact, and this is the output A. Now you can see that we have to keep the blower on throughout. Since we have to keep the blower throughout on, this output A is connected to the blower. Now the sawing machine, that has to be connected to this terminal. Okay, this CR022 terminal. Now when this particular switch is on, it will also trigger the timer unit. Once the timer unit is triggered, it starts counting for this 4.5 second. Now you see particularly that which particular terminal of the timer unit has been used for activating this relay. Now in order to activate this contact, we have used TT terminal. Since it is TT terminal, as soon as the counting starts, this terminal goes high. Now this terminal will go high, and as soon as the counting stops, this terminal will go low. So what we have done, we have kept an associated NO contact. Please remember, this is going to be an NO contact, not the NC contact. Okay, if NC contact is there, then this thing will not happen. So it will be an NO contact. Fine. So whenever the counting starts, this NO will become NC and your output will be activated. Whenever this counting stops, this NC will again turn back to NO and your operation will be stopped. Now you see, operation will be stopped means only your sawing operation will be stopped. However, the blower operation will be continued unless you stop this IN001. I hope it is clear to you. Let us go for next operation. Here we need to see what is a pulsed repetitive timer operation. The situation is like that. We are in a paper mill. As the finished paper comes out of a paper machine to the finished roll, a roll number is to be printed on the edge at the intervals. Now the number should be printed once in every 12 seconds. That means after every 12 seconds, the roll is continuously coming out. After every 12 seconds, there will be a punch maybe, or an electropneumatic assembly that will put a printing say stamp on the paper. So for this, what we have done, this is the timer block. Here is our input. Once it is done, we activate this input. That means this is an NO contact, it will become NC. That we will do externally. Once it is done, after 12 seconds, this coil will be activated. Now once this coil is activated, your printing will be done. Now you see beautifully what we have done, that there is the NC contact associated with the coil, which is connected to the reset input of the timer. So whenever this coil is activated, this NC contact will be deactivated. Once it is deactivated, it will reset this timer, and again the timer will be in its earlier condition. So once it is on, this continuous on and off operation will be continued, and therefore you will be getting pulse at the output. Let's go for the next operation. Here we have got a one shot system. Now you see the application is there, where we can find that an alarm is to sound for 17 seconds after a machine is started, to alert the personnel working in the area that the machine has been started. So this is a clear one shot system. It will work only once after the machine is on. I will not explain this particular system in detail, because already I have shown you one shot system earlier. So this has been kept as an exercise for you. Just you put your brain teased over this particular solution that I have given to you. In the next operation, you can see that there is a cascaded output system. So what is a cascaded output? One after another. When one after another timer comes into operation, we call it a cascaded output system. Here you can see a metal bar has to be held in a fixture. Okay, and in order to hold this metal bar in the fixture, 3 hydraulic press operations has to be done. Initially, hydraulic press 1 will press it, and it will stay in the pressed position. 5 seconds later, another hydraulic press B will press it from another direction, and it will hold the position. Finally, a third hydraulic press comes into play from a third direction and hold the position. So now this is very simple. With the press of a switch, the first hydraulic press will be in operation. After a time delay which is decided by this particular timer block, the second hydraulic press will be in operation, and after that the third hydraulic press will be in operation. I don't think there is much to talk about this particular problem, because already we have talked about cascaded output in our earlier lecture. Next comes the dual time delay off. Dual time delay off. You can see here what is the operation. When the lights are turned off in a building, there is a building, when all lights are turned off, only there is an exit door light that has to remain on for additional 42 seconds. That means there is one off delay timer working. In addition, the parking lot lights are to remain on for another additional 3 minutes. So once you put off the main supply, for 42 seconds, the exit door light will remain on, and after that for additional 3 minutes, the exit parking light will remain on, and then all the lights will go off. Okay. So you see here, the situation is all the lights are off, then the exit door light will remain on for 42 seconds, it will go off. In addition, the parking lights are to remain on for additional 3 minutes. So after that lights are off, this exit door light will remain off for 42 seconds, whereas the parking lot light will remain on for another 3 minutes 42 seconds after the main lights are off. Let us see how this has been accomplished. Now you can see here, this is the main connection. This is the main connection where the lights IN001 is closed during the plant operation. When this is closed, all the lights are closed. Now you see, this is the door logic. This is the door logic, and this is the door light. this entire this part of circuit, this upper part of circuit, we have already seen in one of our delay operations. Now what happens that in addition to this delay, there is another delay circuit which has been invited into this operation. So after this particular delay is carried out, there is another delay. But here you can see that there is no cascading, because we have said that this parking light will remain on, exit door light both will remain on initially. So you can see there is no cascading. You have seen that this is one contact, this is another contact. Do you find any cascading here? Not at all. There is no cascading. Therefore what will happen, that there will be single delay off, then there will be another delay off. For the first delay off, the delay is of 42 seconds, and for the second delay off, the delay is of 3 minutes plus 42 seconds. So this you need to understand out of this circuit. I am not explaining the circuit because we have already explained one circuit. You just divide this circuit in two parts. This is the upper part where the door light is handled, and this is the lower part where the parking light is handled. These are two separate circuits. However, they have to be combined because the operation is a combination operation. Now let us see one industrial process timing application. This is purely a very heavy industrial process that we will discuss. Here we are discussing a heat treating machine that carries out a surface hardening process on a steel ring. The steel ring is heated to a very high temperature, then immediately it is cooled very rapidly. This is what is called as quenching. This is the basic process of heat treatment. The metallurgical result is a very hard surface on the steel ring. This is a common metallurgical process, and heat treatment is also very common in this forging plants as well as metal treating plants. Now you see what is the situation. Heating is done by a non-contact induction heating process for rapid heating. So induction heating is a process that is extensively carried out in industries. This is a heating process that is carried out by exercising eddy current heating. Okay, now you can see that cooling water is circulated through half of the induction coil to prevent the ring from getting overheated. The quench is done by spraying cold water on part finally. The quenched water is pumped into the inner half of the induction coil, spraying the part with cold water through many holes inside the coil, result in fast cooling. So this particular paragraph that describes about the process. The first paragraph that describes you the metallurgical process that is taken place in a heat treating machine. In the second part, we are getting description of the operation. I am not trying to make you understand this operation. I am just showing you one case where the timing applications are required. Now you see that this is the mechanical layout of the entire heat treatment system. This is a pneumatic cylinder. This pneumatic pressure will push it up, and either gravity or spring will let it down when the pneumatic pressure will no more be there. So there is up down switch on the left side, there is also up down switch on the right side. In many cases both the switches are to be acted simultaneously, because this up switch and up switch both has to be pushed simultaneously, so that there is a two-handed safety system achieved in this circuit. Next, this is the system on off, and finally here there is the special part where the ring has to be inserted, and you can see here actually the ring has to be inserted. Here this heating coil is there. You can see this is the C. You can see the heating coil cross section where there is cooling water passing has been shown also. So you can see this Q is the quench water. Okay, holes on the inner face for quench spray. This is the quench water, and this is the cooling water. So finally you have come to understand that this is the heating and cooling part, wherein this entire assembly do enter. The heating is done, then the quenching is done, and after the sequence of heating and quenching is over, then the thing will be coming down. So now you see what is the processing sequence. The master push button is first depressed to turn the system on, then the part is placed on the mandrel. Here you can see, here is the part is placed, this is the mandrel. Okay, this is the up down mandrel. Now you can see both left and right startup buttons are depressed. You can see this up button on the left side and up button on the right side, they have to be depressed concurrently, so that none of the hands of the operator is free. Because if the hand of the operator is free, then due to some accidental condition, the hand may get I should say entangled into the system. The hand may get in within the operation, and your hand will be completely damaged. It has to be amputated. So in order to get rid of such situation, these two-handed safety circuits are always designed for such operations. Now you see that at any point of time, pushing any stop button should stop all operations immediately. So you can have stop buttons at many places. You have gone off button here, you can hit stop button at different parts of the circuit which are near to the operator. Now you see the part is raised from bottom to top by pneumatic air operation. A solenoid valve supplies this air to the pneumatic elevating cylinder. So you need a solenoid valve through which the air will enter into the cylinder, and this will push this entire mandrel up to the cylinder. The lower limit switch must be actuated before the part will rise. You can see this is the lower limit switch. You can see this is the lower limit switch. Okay. Lower limit switch action indicates that there is a part on the mandrel and that the mandrel is down. This limit switch opens as part leaves the bottom position. So whenever this part will be raised, then this particular switch will be deactivated. Otherwise, when the mandrel is in its home condition, this switch will be remain depressed, which shows you that actually the mandrel is having the part loaded, but yet it not has started its upward motion. The moment upward motion is started, this switch is deactivated. The mandrel makes a contact with the limit switch at the top of the trouble. You can see there is also upper limit switch. So when the mandrel reaches the extreme limit of the upper position, that is, it is well within the enclosure of this heating and quenching station, then the upper limit switch is depressed. It means that the mandrel should stop its operation. So somewhere the control of the upper limit switch is going to the you see the solenoid. That means it is going to one of the input terminals of the PLC, and when this switch is depressed, the PLC understands that the pneumatic cylinder has no more to be supplied with air, and it stops the supply to the pneumatic cylinder. Now the mandrel makes a contact with limit switch at the top of the trouble, and after this switch is depressed, this mandrel stops its operation. Now you see heat comes on for 10 seconds. At this point of time, the timer comes into action. Heat comes on for 10 seconds and then it goes off. Then the quenching comes on for 8 seconds and it goes off. Now the part will return by gravity and spring action. Why it is not completely gravity? Because if it is complete gravity, then it will fall freely at a very high speed, which is not advisable. The upper limit switch becomes inactivated when the mandrel starts down. Definitely when the solenoid will be no more allowed to enter to supply air into the system, then solenoid valve will change the direction, and now what will happen, air will go out of the cylinder and this mandrel will start coming down. When it will start coming down, this LSU, that is the upper that limit switch for the upper limit motion, that will be deactivated definitely, and the system will understand that the mandrel has started its downward motion. Now the part and the mandrel reach the bottom. When the part and the mandrel reach at the bottommost position, the down limit switch is again actuated. You can see here is the down limit switch. When the mandrel has reached its bottommost position, this particular limit switch, it is again actuated, which shows that the mandrel is in its home condition. Now the system will reset and the part has to be removed. Okay, so this is the entire situation. Now we have not I should say inculcated or introduced several of the factors which will make the system more complex. Now you see there should be interlocking at the heat generator and water pump, that the heat generator and the water pump should not work simultaneously. So this should be taken care of by an interlocking. So this has to be done at the PLC end. we need to ensure that same ring part is not processed 2 or more times. Now it may so happen that the mandrel has come down. The mandrel has come down. This particular thing, it has understood the mandrel is loaded with the part, and then the person who was actually pushing this up switches or the down switches, he will again put the up switches in operative condition. That without unloading this part, he is again put the up switches on. This may so happen accidentally or by some fault by the operator. So that should be ensured that once a operation, heat treatment operation has been carried out on a certain ring part, it is not processed again and again. Now a thermocouple can be incorporated to monitor the process temperature. Then your analog operations will be started with the PLC. The manual controls for up, heat and quench action should be added, because if somehow the automated operation is breakdown, then at least manual controls will be on for up, getting the mandrel in upward direction, heating and quenching of the process. A safety shield can be automatically lowered during heat. When the heating coil is heated but the heating coil is energized, then there should be a safety shield that should come down, so that the operator who is actually pressing the up or down switches, he does not feel the heat. And if a power interaction takes place during the process, where from the process should restart. This is very important to understand, because suppose the power has gone up, the power is on, the process is on also, the power has gone off when this mandrel is in some mid condition. So after the power is on, you must decide that where the mandrel should go in the upward direction, or it should come down to the home position. What should be the condition when there is a power failure, and on power reset, where the system should find itself. This is one important aspect that should be taken care of. Now this particular example I have deliberately given in order to show you that what complexity is there in a very simple manual operation if we want to make it automated. Because if this is a manual operation, there is no problem. You put the part, you put the up switch, you, once the system reaches there, you put on the heating coil. After 8 seconds you put off the heating coil, then you put on the quenching water supply. The quenching water supply will be there for another 5 seconds, maybe you put it off. This is very simple so far human brain is concerned. But when you need to automate the system, you have to take care of so many things. Just to show you the complexity of industrial operations, I have given you this example. I hope that timer section is now well clear to you with many of the examples that we have discussed. If you have not come across any of the points, let me know. But I really suggest you that you again and again go into the problems and get into the ladder diagrams, so that you can be very versed with the systems that have already been discussed. So thank you for now. In my next lecture I will discuss on counters. Thank you.